Hi, today I want to talk about sharing with the HoloLens, specifically around how you can have multiple users in the same physical room interacting with the same content, or even inviting users from outside of the room to interact with that content. Now, you're probably like me, the first place you went to was Holograms 240. Now, I watched all these videos multiple times, read through all the notes, and still I never really understood exactly how it works. Multi-user networking with HoloLens is definitely the most complicated part of my journey so far in deep diving into HoloLens technology. So today I want to help demystify how to do multi-user experiences and hopefully help you get back on track if you're a bit confused yourself. So this page itself should probably come with another warning, maybe like that's what we need. Don't panic. We can understand how to build multi-user experiences. So the first thing to understand is that there's nothing actually built into HoloLens to enable multi-user experiences. You need to use a third-party library and do the networking yourself and build up a solution pretty much from the ground up yourself. So what's the most important thing to understand with a multi-user experience? It is back to our friend, the anchor. The most important part of a multi-user experience is having a shared anchor in the same space. Now, an anchor you can attach to a game object in Unity, and it'll make sure that the transform is at the correct position and the correct rotation. Now, when I first started using anchors a few weeks ago, that was really cool because I could spawn some content in my scene, in my room, attach an anchor to it, save that anchor to the anchor store. I can reboot my HoloLens, I can do whatever I like, but when I restart the app and I reload the anchor, the content is back where it should be. That's massive. But what I didn't realize was that you could actually persist those anchors across to another HoloLens device, and it too will make sure that that content is in exactly the same spot. Now, it doesn't matter if those HoloLenses were launched the app from two different locations in that space. If you remember, when you first launch an application with HoloLens, the coordinate system origin is basically exactly where your HoloLens is looking. So that means that if I launched it in room A, then my origin will be in room A. But if you launched it from room B, then your origin will be in room B. So we can't just share the location of a game object between our two HoloLenses, because if I told you to spawn your content at the origin, you would end up having it in room B and I'm in room A. But the World Anchor system helps us get around that, because the HoloLens, while it's scanning, will look for that anchor and will know where the content's supposed to be. So that's actually the most important part. That's the real takeaway from that whole page on Holograms 240, is that you want to have an anchor, and then you want to share that anchor between your HoloLens users so that they can make sure the content that they spawn is either at that anchor or relative to that anchor. So probably you're going to have multiple pieces of content, and you're not going to have them all sitting on that anchor. But the good thing about the anchor is, because it includes orientation, it means that if your content is relative to that anchor, so say it's 2 meters away down the z-axis from that anchor, then we'll all see the content at exactly the same spot in the room. So what we want to do is get this shared anchor. So how do you get one HoloLens that has recorded that anchor to share it with another HoloLens? What we need is some kind of networking system to do that. Now, in the mixed reality toolkit for Unity, we can find that there's actually two different solutions that Microsoft have for us to look at. One is based on Unity's built-in networking, UNet, and the other one is based on a system they call the Sharing Service, and that's the one they used for their NASA demo and a few other demos. Now, the Sharing Service is actually built on top of an open source multiplayer networking system called RACnet. RACnet was acquired by Oculus in 2014 and then open sourced, and it has amazing features for doing multiplayer games. It includes connection management, user management, session management for those users, messaging, being able to send messages between users or broadcasting to all users in a session, priority of messages, routing rules with messages, whether it should be on a session, on a TCP reliable kind of session, or whether it's on a UDP unreliable session, what you should do with old packets, whether you throw them away or whether you keep them. And then it also includes a few high-level kind of features such as voice over IP and the ability to sync data, or elements as they call it. So that if someone creates several elements, when a new user connects into the server, it automatically downloads those elements. So it really is everything you need to build a multiplayer experience. And because it's high performance and written in C++, it's really fast and it's perfect for real-time augmented reality solutions. So you can find all the source code to this in the Mixed Reality Toolkit, native toolkit, not the Unity one. So if you actually want to dig in and see what this code's doing, you can find it there. The feature of RACnet that makes it applicable to Unity is that there are ways to generate wrappers to this native SDK so that it can be used in other platforms such as Unity. So the RACnet SDK itself is a bunch of DLLs, and then we get a wrapper so that Unity can call into those DLLs. So how does it work? It's basically a client-server system. You run the sharing service on, say, a PC in your network. If you wanted to get the code yourself and compile it, you could compile it into Linux or something else, so you could host it on the internet. Just to get you started quickly, Microsoft have pre-built it for Windows, and they include the executable inside the Mixed Reality Toolkit for Unity, so you can launch it. And then it has a bunch of prefabs and Unity components, so you can actually interact with the service. Now, the service itself is not just a generic RACnet server. You could use it that way, but it actually has code to support the idea of sharing anchors. And essentially what that means is you could take that code and you could extend the server to have features that you want for your application if you want to. This way you're not relying on just clients controlling what's going on. Having a server that actually is an authoritative server, meaning that the server actually has logic in it for your app and it makes decisions on what should happen rather than just your apps sort of generating anchors and broadcasting them out to other people in the game. Having a server authoritative means that you can sort of control that better. So that's what their example does. So let's have a look at how you can use that from Unity. I'll switch over to Unity here. So there are two scenes in the Mixed Reality Toolkit for Unity related to RACnet sharing. One is called Sharing Test, and the other one is called Sharing Spawn Test, that one there. So Sharing Test is the simplest one. First thing you're probably asking yourself maybe is, well, how come it's got test in the name? The way that Microsoft has set up that repository is that if there are a bunch of components that you just drop in and use exactly as they are without changing them, then they're not in the test section. That's basically like the spatial manager and the spatial perception and spatial understanding. Generally that you're dropping those components into your app and just using them. But for multiplayer networking scenarios, They've put the code in the test section of the repository, and what they're trying to suggest to you is that you would probably take this code and modify it to suit your application's need. And they're probably not prescribing to you that you should use their components just as they are, because they're really specific to the particular solution that they're presenting here. Now, there is a prefab called the Sharing Prefab, and it has 2 scripts on it, and you can basically use these. So the sharing stage is the main script dealing with communicating to the server. So the first thing it's going to want is the address of your server. Now, by default, this is localhost, but I've plugged in this IP address. That's the IP address of my machine on the local network here. Where did I get that from? And how did I know to plug that in? Well, let's find the server. So the pre-built sharing service can actually be accessed under the Holo Toolkit menu, Sharing Service, and Launch Sharing Service. Holo Toolkit, Sharing Service, Launch Sharing Service. I'll drag that over. So you can see this service is just a Windows executable. It's running in a command shell. You can actually run this as a real Windows service, so it boots up when your machine boots up. And there's instructions on how to do that. But I'm just going to keep it running here on this terminal. And you can see there it says the IP address that's detected of the local machine. So I just copy that IP address and I plug it into Unity. Make sure you don't leave anything highlighted in this window, otherwise it'll be locked up and won't respond. And it's now listening on port 2602 here, 2602. There's another executable that they give you as well, which is useful. If you go to Holo Toolkit Sharing Service Launch Session Manager, then this is just a UI that kind of tells you what's going on with the sharing service. So it's just telling me that there are no users currently connected to it, which is correct. The green dot means we are talking to it. From this UI, I can actually also join in if I wanted to into a session. And that can be useful for debugging and just being able to have another user in that session. Again, the source code for this one is available in the native Git repository, so you can come and modify this if you need to add features to it. But I'm just going to leave this as a way for us to monitor how many users are actually involved right now. So back to this script. So basically, we're going to plug this address in, and we're going to connect on awake. So if we run this app, this would automatically look for a server at this address, connect in, and enable us to start talking to the server. There's a great little property here called Auto Discover Server, which would be really awesome because then we wouldn't have to put in a server address. But this doesn't work. I can see a couple of GitHub issues logged about 9 months ago that it stopped working, and there doesn't seem to be any fix being rushed out. Maybe by the time you're watching this there is a fix, but right now if you tick that box it won't auto detect the server, so you need to put in the IP address of your server. You can leave it localhost if you're running in the emulator. I've got a real HoloLens device here, so I'm going to use the IP address. Now, having a connection to the server is great, but we actually want to join a session. A session lets us separate users, and so we're just going to connect automatically to a session called default. And in our UI, that kind of shows us that right now we do have a default one, but there's no users currently connected to it. Now, this is all you need to add to your Unity project to have it connect to the server and maintain a session. But what do you actually want to do? Well, the first thing you want to do is that anchor that we talked about. So in this demo, it actually does do that. We have a game object here, and there's a script called import export anchor manager. And what this script is going to do is create an anchor for our hologram collection. So this will be the actual shared anchor game object, and we'll create a anchor for it, and then our game objects, which is this sphere here and this text, is going to be relative to this anchor. So basically the proof that this thing works is that if we have multiple HoloLenses and this anchor, this sphere is in the right place for all users, then it's working. So this is a very simple demo, but really important that you run this and make sure this actually works. So architecturally, let's just jump back to this diagram here of what it actually does. So we have our sharing service, and like I said, it involves the RackNet code base and then some specific features just for HoloLens. And the features that are in there are essentially, there's the concept of a room, and the room is supposed to mimic your physical room that you're in, and then each room can have anchors, at least one anchor. And then basically, if I've connected in, created this room, uploaded my anchor, and then you come in and you join the same physical room, then you'll want to download my anchor. And by building this into the server, then our client can interact with these parts of the server. And if we go back to Unity, we'll see that this script is actually the one that does it. So I'm just going to grab this script quickly. So if you look at what this actually does, let's have a look. Its job is to get us to the point where we have an anchor. So there's a bunch of states it's going to move through, from starting up, creating, initializing my room, creating an anchor, getting into the anchor store. We need to get it into the anchor store so that we can then persist it, and then we're going to try and export that anchor, upload it to the server, request that we can download the anchor and import it if we do find one. So let's see where the important thing is. Skip down a little bit here. And as I said, it's very complicated. So if you can understand this more quickly than I am, then more power to you. Just going to come down here a bit. Okay, so if we come down here, the export function. So once we've actually acquired an anchor, we're going to export it. And so here we can get our world anchor because it's been added to our game object. So we can get our world anchor. We can then save it to our anchor store. And then once it's saved, we can actually say we want to export async. So basically we're going to say export it out to us and call the stream it into the right buffer. Now the reason I think they do that is because it's the size of the anchor is quite large. I think it's about 1 megabyte, but it could be more than that. So using this async method, we're going to write it out to the buffer, and then once we've streamed it out to that buffer and we're done, then we're going to call export complete. So the streaming happens down here. It just keeps adding the data to our array, and then eventually we call export complete, and we can actually get the data out and upload it to our room. And then once we upload it to the room, everyone else can download it. So let's run this up as a little demo. I'm going to switch to put my HoloLens on. Inside HoloLens, I can see the Unity logo, and now I can see that we've connected to the server. The room we've connected to is we've created the room, default room. We're actually in the room now. We found an anchor. We exported it out. That took a little bit of time, probably about 5 seconds maybe. And now we're uploading the anchor, and now we've successfully uploaded the anchor. So the ideal way to test this would be to have a second HoloLens. I only have the one here, but what I can do is I can run Unity, and we can have Unity be another user. So we'll hit play. So we can see in Unity now it says no server connection. Then we've connected, we've joined the room, we found the anchor, and we've downloaded the anchor. Now, how do you know that that's actually working? So first thing is we can check our session UI, and I can see we have 2 users in there now. HoloLens ID, that's me in the actual HoloLens, and Peter, that's my local machine here. But further from that, what we can do is if we look underneath our anchor here and we come down to cube, this demo actually will put a cube over everyone's head. So this cube here, if I look at it in the scene, is actually my HoloLens head. If I turn my head like this and up and down, it's actually replicating into the Unity scene, and you can see it very quickly. So there's very low latency on my Wi-Fi network. Now I can do the reverse of that. I'm looking through my headset now. I can actually just grab my HoloLens camera in the scene, and if we zoom in on that, I can move that around in this space, and through my HoloLens I can actually see that cube moving around. I can rotate it around, and it rotates in my HoloLens, so I can see it again very quickly in real time on my Wi-Fi network. So that's really great. And the way that cube is controlled is this script here, Remote Head Manager, which is basically sending out the main camera's transform to everyone in the network in real time. So that's a deep dive into this scene. Now I'll stop that. Now a secondary thing I want to talk about is how do you spawn your own content. That's probably the number one scenario, is that you're building a multi-user experience, you want to spawn some content. Let's say it's a city, you want to put it in the room and have people interact with it and things changing in the city. So the way you could do that is, if we look at this other scene, we'll go to Sharing Spawn Test, and if we look in this scene, we'll see we have our Sharing Prefab, although it's got an additional script here called the Prefab Spawn Manager, and then we have a sharing stage, which is going to be basically our shared content is going to sit under this. Actually, the spawn target will become our anchor, and all the content will be instantiated underneath this anchor, and then everyone will see it in the same room at the same place. So how does this work? I decided to create a diagram to make it much simpler. I couldn't find a lot of good documentation for this, and hopefully this will help. There is basically 2 things you need to do. One is you need a data object, which is based on sync spawned object, and sync spawned object is going to represent whatever the data is, and it's going to pass around on the network to tell people. So if you had a city, you'd probably have a city sync spawned object. You can put your own data in there. So if you wanted to have the lights on or off, you would probably have a Boolean to say lights on, lights off. If you wanted to do other things in your city, like turn on billboards or add cars or add layers or something, you could basically put all that logic into your synced object. Now, synced object doesn't have any graphical view, it's just a data view. So how do we get our city to appear with people? So that's on this right hand side. You basically use a prefab, and you give the prefab a name. So let me just walk you through this quickly. So you basically start with your code, and someone says, I want to spawn the city. So your code will go and create a new version of your city object. And then you'll talk to the prefab spawn manager and you'll say, take this object and for it I want to spawn a city. And if we just jump back to Unity for a second and we look at the prefab spawn manager, you'll see it basically has a set of prefabs and names. So you probably have a data model name called city, and then you'll have a prefab, which is the actual city that you want to be instantiated into the scene. And so basically your code will tell the prefab spawn manager, hey, I've got my city object, now I want to spawn the city prefab. And the prefab spawn manager will go, that's cool, okay, I'm going to instantiate that prefab. I'm going to put it under the whatever parent your code asks for. In this case, we asked for spawn target to be the parent. And one additional thing it's going to do is it's going to add a component called default sync model accessor to your prefab. If it's not there, it'll add it. If it's there, it'll use the existing one, and it'll save your synced object into that component. So basically your code will be able to access all the data in your synced object via this component. Now, if you're local, that prefab will just be instantiated into your scene and off you go, just like a normal single player experience. But what's actually happening behind the scenes is that it's then going to send the data from your object up into RackNet, and it's going to save that in that session, and all other users will be notified of that this class has now been instantiated into the server. They will download this class, instantiate a copy of it, or create a copy of it, and then they'll go through a similar path. They'll go, okay, so now I'm going to talk to my prefab spawn manager. I've got my object that I've received over the network, and I also received the name, and it'll then spawn, instantiate the same prefab into their scene as well. Now, any client can modify any of the data in there, such as turning on the lights, and that will be replicated across the network, and then your code can turn the lights on or off when that changes. So it took me a while to get to this, but once you understand what's going on, you can actually use the Microsoft RackNet code and build a multi-user experience pretty quickly, and it all just works as long as you stick to using these classes that Microsoft have provided for you.
So here we are in the spawn test. I can see through my HoloLens to my PC screen, and I can see we're both connected to the same scene, and these are all the game objects that have been spawned. And through our HoloLens we can see them all floating in front of me, and all I need to do is just grab the transform and move it around, and you can see that I'm moving that object in the Unity scene, and it's automatically being replicated across the network to my HoloLens. So once we've got a spawned object, we can simply update its transform location, and that will be spawned. Not spawned, will be replicated to the spawned object, and I can also rotate it as well. And scale is probably there too, and scale is there as well. A little bit of lag, but it's pretty good on a Wi-Fi network here.